Let's try another one. Here we have the equation sine of x plus y is equal to y squared times cosine x. And we're going to calculate the derivative y prime. So that means we're viewing y as a function of x. And in this equation, all of the variables, all the x's and y's are kind of mixed together. So really y here is being defined implicitly as a function of x. It's not in the form y equals. So we can't use our regular derivative rules. So implicit differentiation is the way we're going to go. All right. So let's try it out. But before we do, just to notice here, this is what this curve actually looks like. So if we were to graph this equation, we get this kind of really interesting curve here. And so with these equations, we can kind of look at the tangent line to a whole broader class of functions and curves that we couldn't before when we had explicit functions y equals. All right, so just some of these are actually kind of interesting looking curves. But in any case, we want to find y prime for this equation. So we start by just writing down our equation again. Sine of x plus y is equal to y squared times cosine x. We're going to apply the derivative to each term on both sides of this equation. And when we look at the left side, it's a composition. So there's an outer function, the sine function, and then there's an inner function, the x plus y. So we have to differentiate all of this. So there's an outer function and an inner function going on over here. We also apply the derivative to the right side. Now again, there's no addition or subtraction over here. So this is all just, we kind of think of this as just all one big term. There's multiplication here. So we're going to have to do some product rule. And that's because there's a product right here. So again, we're viewing y as a function of x, and then cosine x is a function of x. So we have two functions of x essentially being multiplied together, so product rule. And then over here, like we said, this is a composition of two functions, so chain rule. All right, so how does that look? How does the chain rule look? Well, we start by differentiating our outer function. So the derivative of sine is cosine. We keep the inner function exactly the same, x plus y. And then we take that inner function and we multiply by its derivative. So that's chain rule. So derivative of the outer function times derivative of the inner. Then we go on to the right side, and let's actually apply the product rule now to the y squared times cosine x. So we can write down two copies of our product. In the first copy, we apply the derivative to just the first piece, and then in the second copy, we apply the derivative to just the second piece, and then we put a plus sign right there in the middle. So that's product rule. And again, chain rule and product rule. So we're using some of our more advanced differentiation techniques here to kind of calculate the derivative of these terms that have both an x and a y in them. All right, so then we have cosine of x plus y times the derivative of x plus y. So we keep differentiating. So there's still some things here to differentiate. So cosine of x plus y, we're done with that. Let's differentiate that x term. So now we can just go kind of piece by piece here. What's the derivative of x? 1. What's the derivative of y? Y prime. And then there was a plus sign in between, so that plus sign just stays there. Then we go on to the other side of our equation. We have a y squared that we need to differentiate. So what's the derivative of y squared? Well, it's 2 times y. And we're differentiating a y term here, so we multiply by y prime. Then we go on to keep going. So the cosine x is outside the brackets, so we're done with that. Y squared outside the brackets, we're done with that. And then we need to differentiate this cosine term. So derivative of cosine is negative sine x. All right, so far so good. We have our equation. We're done differentiating. So now the second phase of this implicit differentiation, once we're done with the differentiation part, is to actually solve for y prime. So that's what we want to do. We want to solve for y prime. And it helps when you're looking at this, go through and wherever you see a y prime, just kind of make note of it. So we have a y prime right in here. So we're going to keep that. And on the left side, there's actually multiplication here. So let's do that multiplication. So let's actually take this cosine x plus y, and we're going to distribute it to the 1, and then we'll distribute it to that y prime. So when we distribute it to the 1, it's just going to be cosine of x plus y. And then we'll have plus, and then we'll have another cosine of x plus y times y prime. So we've multiplied this entire cosine of x plus y into this 1 plus y prime. And probably good form to just kind of rearrange the terms. Again, it's not an absolute necessary, but I like to put the y prime at the end. So I might do like 2y cosine x times y prime. We have a negative in here, so it's better to bring that negative. It's easy to lose track of. So let's put the negative in front of that y squared. And now we're probably in a better position to start moving terms around. So we want all the y prime terms. Let's get rid of that last, yeah. So we want all the y prime terms on the left. So cosine of x plus y times y prime, that's already there. Good. This 2y times cosine x times y prime, we want to move that to the other side. And then this cosine x plus y, we want to get it out of there. We want to move it over to the other side. So we're going to subtract this cosine of x plus y to get it onto the other side. And then we're going to subtract this 2y times cosine x times y prime from both sides to move it over. So when we do this, we end up with cosine of x plus y times y prime minus 2y cosine x times y prime is equal to negative cosine x plus y minus y squared times sine of x. So again, if we're looking at this thing, this term was already on the left. The 2y times cosine x times y prime was on the right, and then we subtracted it to move it over to the other side. The negative y squared sine x was already on the right, but then this negative cosine x plus y, we had to move it over, and we did. We moved it over with subtraction. All right, so now we're in a position where we can actually, every term on the left has a y prime in it, so we can actually factor that out. So we can factor out a y prime, and when we do that, we're left with cosine of x plus y minus 2y times cosine x, all times y prime. Not doing anything there on the right, so that just all stays the same for now. And then finally, we want to get rid of this whole term in front of the y prime. So we want to divide. And there we factored before. So we want to take this whole term, once we've factored, take this whole term in front of the y prime, and we're just going to divide both sides by it. So that'll cancel out on the left, and then it'll give us y prime all by itself, and it'll give us a big fraction on the right. So when we do this, we get y prime is negative cosine of x plus y minus y squared times sine x. So what was already there. And then this will be all divided by, and we're dividing by this term that we had left over on the left. So cosine of x plus y minus 2y times cosine x. And there's our derivative. And if you wanted to, you could, factor a negative out or something like that. So maybe there's a little simplifying we could do, but that's pretty good. And for a lot of these implicit differentiation ones, when you calculate y prime, there shouldn't be any y primes over here on the right, but you are going to have most likely x's and y's. That's fine. All right, so there's our derivative. Alrighty. Well, let's see. We've done derivative. We've just calculated y prime, the first derivative, but we can use this technique to calculate y double prime and higher order derivatives as well. So we're going to see that in the next example.